Hi everyone, can you hear me at the back? Yeah, brilliant, thank you. So I'm Ginny Kirkham from the Institute of the Motor Industry, and we've been invited along today mainly to tell you about the qualifications we've developed relating to electric vehicles, but I'm just going to give you a brief introduction as to what we do at the IMI as well. So has anyone heard of us? Have you heard of the IMI, anyone? A few hands there, brilliant. Okay, so who's here with me today? So with this, obviously myself, Ginny Kirkham. I'm one of a team of business development managers at the IMI. I work with and look after our approved training centres in the South West and South Wales regions. I also help to promote the IMI and help grow our relationships with industry partners. Then we've got Hayley Pells, who's our policy and public affairs lead. She's over here. Hayley's job is to get the automotive industry's voice heard. So I would urge you to speak to Hayley. She's essential today. She's looking for some real life case studies to take to the UK Battery Strategy Group, which will hopefully lead to us getting a voice in Westminster. So really important. If you can, have a chat to Hayley. She'd love to hear what you've got to say. Hayley's also recently been heavily involved in the MOT consultation, where the government wanted to lengthen the time period between MOTs. So they want to do 4 years and 2 and 2. With Hayley's involvement and collaboration, they decided to just leave it alone. So you can imagine how influential she is for us. We've also got Jason Embry, who's our product manager at the IMI. He heads up our product team, who develop, update our qualifications, e-learning programs and accreditations, which is an endless task, as you can imagine, especially with technology advancing as quickly as it is at the moment. He also deals with government funding and regulatory bodies rules, which our products have to comply with. Then we've got Ian Watson. Is one of our product developers at the IMI and has recently been working on updating the electric vehicle qualifications, which he'll be telling you about shortly. Okay, so who are the IMI? So first and foremost, we are a professional body for individuals who work in the automotive sector. We've been looking after automotive professionals and their careers for over 100 years now. And at the last count, we had over 105,000 members in 75 countries. We have a public-facing professional register, which lists members, individual members and their workplace. So these members have been recognised for their achievements, experience, professionalism and commitment to a professional standard of behaviours and for keeping their knowledge and skills up to date through continued professional development. We're also an awarding body, the world's only automotive-specific awarding organisation. We've got 300 plus national and international qualifications. We offer industry competence accreditations as well as accredited learning programmes, which have government and British standard recognised quality assurance. So we're also the Automotive Sector Skills Council, more commonly known as the Automotive Standard Setting Body. We do in-depth research and reporting, which can be found on our website. We are an advisory for government on automotive industry, which is Hayley's job, and we cover 24 automotive subsectors. So we help out set industry standards, so the national occupational standards, which some of you in the room I know has been involved with at the moment, recently, with our own Caroline Harris. The EV NOS was up for review, which some of you helped her with. So it's just coming to an end now. And we also grow relationships with industry partners. But what I just want to make clear is what we don't do is dictate what people, employers and organisations must do. What we do is gather popular opinion and industry, automotive industry intelligence and turn it into standards, qualifications and use the evidence to advise and raise awareness. So that's what we do. And about us, so our missions there is, so at the IMI we believe passionate that the automotive industry is a driver for innovation, employment and opportunities and economic growth. The IMI's purpose is to provide and continually evolve the means by which people work in the automotive sector can attain relevant professional competence and appropriate recognition. So it's our mission to make sure that individuals and organisations can meet with exacting standards of professionalism at the digital and AI era will demand. So then we've got TechSafe. Now, I'm not going to go into too much detail about TechSafe, but I just wanted to put it on because you'll see that logo throughout the presentation. So IMI TechSafe is an industry-agreed minimum standard of competence with additional recognition to the IMI's professional register. So it identifies member professionalism and safe working practice in the field of electric and hybrid vehicles and other safety critical systems such as autonomous or advanced driver assist systems. Now we've also recently added hydrogen to TechSafe, and in the future we'll be including autonomous and connected vehicles, cybersecurity and anything else which results in a safety or compliance requirement for the new emerging mobility sector that we're going to see. So if you'd like to know more about TechSafe and which qualifications are eligible for the recognition, and if you just have a chat with one of us later on, we can explain that. Okay. So I'm going to hand you over to Jason and Ian now, who are going to tell you about the new developments in the electric vehicle qualifications.
Thank you, Jenny. Before I start, can everyone hear me at the back? Fabulous, great. Okay, so I know Jenny gave me a bit of an introduction at the beginning, and I will say that photo did not do me any justice whatsoever, although the hair hasn't changed, as you'll notice. My role is, as Jenny rightly said, is product manager. So I've managed personally a team of 5 developers, including myself, who are technically competent in their own right. Now, we used to call them product specialists. Now, over time, obviously, that specialism tends to recede and tend to go away. We need to keep CPD up to date. But more importantly, it's around the emphasis on yourselves and the experts, subject matter experts, manufacturers that we work with, to ensure that our qualifications going forward are valid. Because the last thing we want to do is actually have a qualification that is not valid before it even goes out the door. All right. Ian Watson is one of our developers, so he's kindly come along today as well. So if you have any questions in relation to qualifications for EV, he will be more than happy to speak to you about that, and I will to the best of my knowledge. So what I want to look at is, and Jenny did talk about the Sector Skills Council and Caroline Harris. I want to go through kind of national occupational standards, which is what Caroline worked with industry with. I'm going to talk about the IMI electric hybrid vehicle qualifications that we currently have available. And as you can see, there's 4 currently available there. There have been some changes in the last 3 to 4 months, and we'll go through that as well. So to start with national occupational standards, as we've got there, what's the Sector Skills Council for Automotive Retail? But you'll probably know it as NOS. Now, I know Jenny identified those that have been involved in NOS, and I know Phil has been involved in the NOS at the back. And that was purely around recently EV improvements. And one of the massive changes that we found with the national occupational standards was we currently have a qualification under hazard management, which includes both recovery and emergency services. Now, one of the key aspects with that change was we needed to split them. So we needed to focus purely on emergency services as well as recovery in a separate entity. Although there are some crossover, there is differences. So that's what the National Occupational Standards, they're responsible for dealing with various national occupational standards across the UK. But they look at maintenance and repair from a light vehicle, heavy vehicle sector, land-based, etc., bus and coach. We have vehicle body and paint, electric and hybrid vehicles. They're not new, I'll tell you, they are literally hybrid vehicles, not hybrids. NOS can also be based around regulated qualifications. And Ginny rightly said that I'm heavily involved in regulated qualifications, and that platform is massively changing in the next year or so. Okay, so just to make you aware of that. So what is the National Occupational Standard? Originally developed in 2010, and it included the National Occupational Standard for electric vehicle, and that is an O2, that's just our reference number for ourselves, which is to provide first response to a broken down or accident damaged electric vehicle. Now the NOS is updated every 3 to 5 years. As the IMI, and within our development area, we tend to update EV qualifications on an annual basis. And that is purely because the technology is rapidly changing on a yearly basis. All right, I'm not going to go through all the spiel on there from what each one is, but you can have a read of that, and obviously these slides will be available for you to look at in due course. So the electric and hybrid vehicle qualifications that we currently have, and I will thank Phil and Paul from the earlier presentation because they aligned training up right up to me. So when you think of training, it's very dangerous to have no training at all. So from yourselves, we have 4 level qualifications. So a level 1 awareness. Now this qualification is more to do with those individuals that may have bought electric vehicles, so customers, consumers. It also looks at sales staff, garage staff, whoever wants to look at it. It's a knowledge only qualification, but it does give you a foundation of what electric vehicles are all about. We then have an upgrade to a level 2 award in electric hybrid routine maintenance. Now again, this is steered mainly towards your vehicle technicians in a garage. And with this qualification, it is all around making that vehicle safe. So how to isolate it, and then be able to enable maintenance and repair to take place after that. From the level 3, electric hybrid vehicle system repair and replacement, this again also includes the isolation because they can't do this bit unless they're able to isolate that vehicle safely. And then it's also around testing of not live components, but it does test you components to get you into that mindset. Level 4 is all around the diagnosis, testing and repair of electric vehicles. This one is slightly more involved. This one looks at the battery modules, the cells, the balancing of batteries, and I know Phil has done the level 4 already. Can I have a show of hands to start with how many of you have done IMI qualifications for EV? Okay, so a few. So hopefully these qualifications are available to you. By all means, you can go and do them. We have a number of UK training providers across the UK. So you can look us up on the IMI website and download and find the nearest centre to you. Moving on from that, which is the one that I wanted to really probably focus on, is around the hazard management. And this is the one that will probably affect you as emergency service personnel. Okay, so at the moment, like I said earlier on, we have recovery and emergency services in one qualification. But it became quite clear around 2 months ago that this qualification wasn't fit for purpose because it was trying to cram too much in on one qualification. And there is specific requirements for emergency services that are not necessarily relevant to recovery and vice versa. The key bit for recovery and emergency service in the one is that handover process, which Emma spoke about earlier on. All right, and I'm not going to go into detail around what you should and what you shouldn't do because you are the experts. We take information from the likes of Emma, and we put it into our qualification. So now what we've got is two separated qualifications. So one emergency services and one for vehicle recovery. And I will say they are still under review. So at this point, it's important for me to ask if any of you want to be involved in these reviews of this qualification, be part of our subject matter expert group, get the first sight of what these qualifications include and how they can benefit you as an organisation, then please let us know today and we will make sure that we take your name and your details and get it onto our system. So the key bits. So what does it look like? So we have various learning outcomes. So the way in which qualification is made up is we will have a learning outcome and we will have an assessment criteria. Now we could have 1, 2, 3, right up to about 7, 8 learning outcomes. But within each one of those learning outcomes, you could have 5 or 6 assessment criteria and the content that's related to it. Okay, so obviously, as you can see, it's got types of electric and hybrid vehicles, pretty bog standard, but I think we need to actually understand what you're arriving to and what that vehicle is all about. Working safely with and around an electric hybrid vehicle, so the process is around that procedure. Reducing the risks of injury and encountering electric vehicles. So again, it's all around that scene management, it's all what you do in that process, and safely secure electric vehicle in an instant scene. So there are, and as Emma rightly said earlier on, there is lots of things for you to think about. And I'm sure you're going to go away today with masses of stuff, information coming around in your brains on how to adapt. But what we are doing is putting this qualification together to give everyone the opportunity to be consistent in their approach. Now, we are fully aware of the Chief Fire Council's requirements for this, and we do communicate with them. But the key aspect for us is making sure that there is a consistent approach to any fire service, police, recovery across the UK. Because everyone is different. If there's one thing that's come out of all of the subject matter experts that we've spoken to, vehicle manufacturers, every single person seems to be doing something different. So it's building that consistent approach, okay? Additional content that was put into it is ensuring a vehicle condition is monitored for signs of deterioration and escalation of severity. Now, looking at some of those videos that Paul kindly showed and scared us half to death, that is your severity. But what I will say is it's not every day it happens. Okay, so you just be aware of that. The control measures available to deal with thermal runaway, and again, we've heard a lot about thermal runaway over the last few hours, and the benefits and implications for their use. So we talk around that. Indicators, causes, consequences of thermal runaway. You've heard a lot today already, but this qualification will also tap into that and give you more information. And this is not an exhaustive list, and then actions to take for electrolyte leakage has occurred. So there's lots that are in the qualification. The qualification itself is only a level 2. Okay, but it is a fundamental part of anyone who wants to know about EV vehicles and managing that scene when you get there for the RTC. Yeah, and I know you're probably all sitting there. My previous background before I got into this was accident repair, so I could repair cars. I also done 10 years with 10-year service with Suffolk Fire and Rescue as a firefighter, so I know what you're suddenly going into. So the key point for us is making sure that this information is out there across the UK. Now, we're not the only awarding body or awarding organisation, but this is our solution if it can assist. Who is it for? And I'm not going to read that whole thing because you can do that yourself. But in principle, it's designed for individuals like yourself. Fire, police, ambulance, and so on. Okay, so it is really important. Forget the yellow bits in the bottom there, because like we said, it is under review. All right, so we don't know whether unit reference numbers are going to change. The title of it will still remain as electric hybrid vehicle, hazard management for emergency services. It is still going to be a level 2. We don't know whether the GLH or guided learning hours will change, but as you can see, they're not massive. So it's not a massive big course that you need to undertake. And then TQT is total qualification time. And what we mean by that is anything that's over and above the actual set time. So if you want to do any research, we recommend, 3 hours over a top of what's already there. And that's it for me. Any questions? Yes, Phil.
Timescale on when you think that'll be ready?
Timescale, we're hoping to have this live by probably around end of May, June time. The actual qualification as the joint one is already live. But this newer one, which is more specific to you, individual fire and police, etc., will be around in the May, June. Yes, sir.
What costs do you actually put out? I mean, I know the costs and they're not massive, but just for the audience here today, what sort of costs are there involved in the delivery of these courses?
It's a really good question. And we have no say on that because it will come down to the individual training provider. We will send them and have approved centres, but the cost will come down to the individual training provider that deliver that course. So that's why I say it's really good to go on and have a look at where your nearest provider may be and give them a call.
Leading on from that, could fire service and police service trainers become providers for the training system?
Yeah, we have been trying to work with Morton, and we're trying to see if we can get a centre into there. So yes, it's not impossible. Providing you meet certain compliance, regulatory stuff, then yes, there's absolutely no reason why you can't. Yeah.
Outside of the battery risks and vapor, are there any, is there going to be any content around the other challenges for responders around additional weight distribution, strengthening, and gaining access?
Really good question, but I would say yes, there probably is within the content of the qualification. I have got a copy of that qualification if you want to have a look at it. Initially now, by all means you can do so. I've only got 2 copies, I will add, so we can't give everyone a copy of it. But it is, like I say, it's still in draft. But I'll take your details and we can have you involved in the groups and then put your site across. Yeah.
So you said you're working with a college.
Sorry?
Could we as a fire and rescue service get, you kind of might have answered it, get some of our instructors to a level that we could then deliver that training to firefighters?
Yeah.
Give them that actual qualification ourselves.
Yeah.
Because obviously they're going to be the ones dealing with it moving forward.
Yeah. So yeah, there'd be no reason we'd have to check and confirm that with our compliance team, but I don't believe there is any reason why you can't. Anything else? Thank you very much. Hopefully it was enlightening. And as I say, we're here for the rest of the day, so if you've got any other questions, just give us a shout. Okay? Thank you.
My name's Dave Ryan. I kind of represent motorsport. I work as an e-safety delegate for the FIA, and I also sit on various committees around the world for EV safety. I sit somewhere between Paul and Emma, and when Paul says extrication, what do we do? That's where I step in. I have to train rescue crews around the world on rallies and rallycross, how to extricate, and we've had to extricate people from dangerous cars for real and on fire for real as well. So for us, this is all very real. As a consequence, and this is what I just want to mention about vapor clouds. Firstly, just for my information, how many of you guys understood what a lithium vapor cloud was before today? No, quite a few, that's good. I do this around the world and they look at me like, don't know what you're saying. These clouds are becoming a real issue for everybody. And in America, and this is kind of unofficial, I was on a webinar where they talked this through. They done some testing on race overalls. And what would happen if you set off a lithium cell alongside a Novex race uniform, which is 2 layers thick. This is one cell. They talked about the batteries having anything from 4,000 to 7,000 cells on some of these cars. I'm talking about one lithium Samsung 3.7 volt cell. They set it on fire. It blew a hole through the race suit, clean through, about so big. That's one cell they set off. As a consequence of that testing, and this is just what I want to make you aware of, I'll try and get some proper data through to John, which he can circulate when it's available. I've asked for it, but nothing's come through as yet. And I don't understand your fire suits compared to the American fire suits. I don't know what the standards are like. It's not really my world, but they thought they'd test one of your firefighters' jackets. So they got a piece of material, 5 layers thick apparently, put it in a jig, and they gassed and blew a single cell underneath it. You'll be glad to hear it didn't go through. But what it did do was some gas residue went into the layers of the material and then ignited. Now, I'll leave that with you. You can imagine you are now holding a fire on you can't get out of. So when you see videos of the guys with the blankets and they're walking around and you see these vapour clouds, and you see them because they think they've got breathing apparatus on, that they're safe. Be aware, these things are very dangerous. Go into them and out of them as quickly as you can. And as I'm off to Kenya next week doing more training, we will be telling people, ventilate your suits as soon as you can. Give them a chance to breathe, get the gases out of them. We don't know where this is going to go, it's very early days, and I will pass the data on as soon as it comes out, but it's just a bit of a follow-on because they never mentioned it. I don't know if Paul's aware of it yet. This webinar was only a few weeks ago and the data is not available as such, but be aware, if you have to operate around these vapour clouds, and we do this in motorsport, we tell them you're in and out as quickly as possible. When you talk about a distance, nobody needs to be nearer than 10 metres. Once you've got people out of the car, and if you've got, someone mentioned about, I don't know how you deal with extrication in the real world. In motorsport, we have highly paid drivers who understand the risks, so we'll pull them out by the ears if we have to. We have some proper techniques, but we will do a rapid if we have to. And if we think that the battery is starting to react, it'll be a rapid, and nobody goes within sort of 10 metres of that, and you watch for the wind. But just the point was, just really be aware of your PPE. You're not bomb-proof, and these initial tests have shown, undamaged, it allowed the gas into the material, and then it ignited. And that would be horrible for anyone that was put in that position. So speed, they don't really emphasise it. I do real world, like you guys do, real world extrications. Speed is essential. Get in and get out. It's horrible. I breathed it in. I had a car fire in Japan 18 months ago. I went back 4 hours after the fire, and it was venting. You could see it. Where the battery sat on the hybrid, there was some fumes coming off of it. I was sick for 2 days. I was near that car. There was no smoke. It was just, you could just see some movement. I was there probably for about 15, 20 seconds. I did a short video, and then I had a headache and I felt sick for 2 days. So speed is very much is essential in this. But please bear in mind, if you do go to one of these things, take your kit off as quickly as you can and ventilate it as best you can. I don't know how that will manifest itself. And as I say, when we get some more data, I'll get it through to John and see if we can get it distributed. But be very wary. They're horrible things. Horrible. Anyway, that was it for me. Thank you.
Lovely, thanks so much, very informative.
So, hello, I'm Andrew. I'm the Sales Director at Rosenbauer UK, and today for the slides I've prepared for you guys, I wanted to talk to you about the challenges that we have as a manufacturer developing equipment for EV response. I want to talk to you about where we're at the moment with our RFC battery technology, also to address some of the misinformation that's out there in terms of what we're doing, and also address the elephant in the room that was brought up this morning by the first speaker in terms of some of the stuff that we have been doing, what happened, why it happened, and just give you guys a bit of an insight into the challenges that we have. So in terms of market electrification, the transport industry is seeing...
Andrew, sorry, I'm at the front here and I'm struggling to hear you, so the guys
Sorry,
at the
mate.
back have got no chance.
Sorry, I've got the mic, but I thought I was loud enough, sorry. So with market electrification, the transport industry is seeing an absolute increasing push towards so-called greener technology and methods of transport. For us as a manufacturer of response equipment, we have to look carefully in where we put our R&D budget. It's unclear if EV technology is bridging technology towards going towards hydrogen, and whether it really is the long-term future of motor transport in place of combustion engines, or whether EV will be the way that it goes forwards. We are also, as you know, a vehicle manufacturer, so not only are we having to develop equipment in terms of response for firefighters to address EV fires, but as some of the other presenters have talked about this morning, and the manufacturers of EV vehicles in terms of how you incorporate that into your vehicles, we develop and we're making our own EV vehicles. So we have to not only develop the equipment for response, but also how we can make our vehicles better for responders to address. So the bottom one we've got here on your right is our RT truck, which is completely built by Rosenbauer. We're not using any other manufacturer's parts in it. So we know that we have to also address the issues that go into responding to it. In terms of combustion fires in electric vehicles, combustion engine fires are relatively easy to respond to. I say relatively easy because obviously every scene different, depending on the nature of it, and in terms of the response that the firefighters and the fire services have, there's more standard practice that goes into the response for it. There's sufficient experience so that when you guys turn up to the scene, you know how to respond, you know what the best practice is. But with EV being such a new technology, that best practice and that guidance for you guys hasn't been produced. And for us as a manufacturer then, we're trying to develop equipment ahead of that guidance coming forwards. It's a huge challenge for us. Like I said, vehicles with combustion engines are relatively straightforward because a combustion engine vehicle normally has the same features, right? It's got an engine that's mounted in the front in the bonnet, you've got a fuel tank, you've got fuel, whether it's petrol or diesel, doesn't really matter. And despite the manufacturers, cars with combustion engines are relatively standard in terms of the layout, the construction, and everything that goes into them. And an EV fire can be a combination of two different fires. So a lot of people this morning have talked about thermal runaway, and while that is the case, each EV fire has two problems. A burning battery will set the car on fire, so that's something that we have to address. But a burning vehicle may set the battery on fire. So when you see an EV fire, yes, it can be from thermal runaway, but it could be from other sources that's caused it. So we have to have equipment that can address all scenarios. We also have the challenge as a manufacturer that EV battery design isn't uniform. We have pouch, prismatic and cylindric cells that are used within the cars. And to give you an example, like we've got there, Tesla Model S, 7,000 cylindrical cells in a battery pack, where the VW ID4's got 300 prismatic cells within the battery. So how do we address that? The constructions aren't uniform across them. So it may be that it requires different kinds of intervention. It may be that it requires different tactics, and they're just not uniform. And that is a challenge for us as a manufacturer. The battery locations is also a challenge for us. We've got to develop equipment to respond to fires within these vehicles. And while there are guides that are out there that detail what the layout are within a vehicle, they're not always in the best place. Ideally, if they're underneath the floor pan, that's the perfect location for us and for the solutions that we've come up with so far. But it can be that they're in the boots, they're in the side, particularly with larger vehicles like buses and trucks, they can mount them in the roofs. we have to try and respond to this, and we have to try and figure out a solution for trying to get to them. RTCs as well present even more challenges on top of the diversity that you've got within the vehicle design. So, to bring them up here. First of all, is the vehicle on all four? So if there's an RTC incident, there's a fire, could be that the vehicle's on its side, could be that the vehicle's on the roof. When that happens, quite traditionally, they put the battery packs within the floor pan of the vehicle. So that presents its own challenge for us to get to. With an EV RTC, does it always lead to a fire? So like I said earlier, an EV fire might not necessarily come from the battery. If it's involved in a collision with a combustion vehicle, it could be that the fire that's there is actually come from fuel spillage or something like that. So do we always need a specialist tool to be developed for it, or do we need something in case the batteries themselves catch fire? Where is the incident taking place is a huge one for us. If the incident's taken place on a country lane in the middle of nowhere, different tactics can be deployed. If it's happening in the bustling city centre, if it's happening in a car park or something like that, it's busier, it's crowded. How do you respond to that, and what kind of equipment do we need to go into that? What resources are available as well is a huge contributing factor. So in the big metropolitan areas where there's much more density, you can have more of a fleet of vehicles for responding to different ones. Whereas if this happened, I don't know, in the back roads, in the Scottish countryside, could be that the nearest station is just a retained station. What resources do they have there for that? As vehicles go further and further, it's not necessarily happening in the ideal situations. Third-party risks as well at the scene. So, yep, it could be that you've got fuel, you could have pedestrians, people involved in it, there could be animals. So we have to look as well as what else is going on in the situation. How do we approach it from our side? So what we have to do is we have to look at the fire triangle as the starting point. So oxygen deprivation, it's not always possible. So there's oxygen present in the battery, there's fuel sources in the battery, and they're producing their own fuel for doing it. So we can't always go down the traditional tactics of trying to go for oxygen deprivation. Somebody asked me earlier about medium for doing it, and medium's going down the route of oxygen deprivation. The batteries have it there themselves, and they're producing it. In terms of removing the flammable structure, the batteries are screwed and secured into the vehicle, so it's not as simple as way as taking away the fuel source for it. So from our point of view, the simplest, most immediate way that we can address it is through heat extraction. So with sufficient cooling at the temperature source, you can stop any of the separators melting if it has gone into thermal runaway and causing further short circuits. And water has one of the best heat removal properties that we can use that's readily available. So the system we come up with is the Rosenbauer battery extinguishing system. So the philosophy that they adopted as a company is to pierce the battery is the most efficient and can be the most fastest method to stop thermal runaway and for cooling the batteries. So we're trying to make it as safe and efficient and as fast as possible. The system itself, we have a control unit which has compressed air cylinders on it. For the small one we've got here, we use two 1 litre 300 bar cylinders. We have adapters that we can use to put BA cylinders onto it for using what's available on an appliance at a scene. We've got a pressure gauge on the cylinders so we can monitor what pressure we have left in the cylinders for deploying, and also monitor what's going on within the system. We have a manometer that's got the working pressure, so we know from the water that's going into it exactly what pressure we're inputting onto it, which is important for one of the points I'm going to raise later on misinformation. We have a switch, which is the easiest way to activate the system, particularly when you're wearing full firefighter PPE. We have a button to vent the system so we can remove that 300 bar pressure, because obviously it's one thing to deploy it, but then after the fact we have to be able to retract it and bring it away. And then we have a hose package. We're using 8 meters as a standard length. 8 meters is to keep anyone that's operating the equipment as far away from that vehicle as possible. There was one of the points that was brought up earlier that the gas exhaust vent can pierce through PPE. So we're trying to keep the firefighters away from the vehicle and from the fire as much as possible and the hazards that could be involved. So they're the two main components there. So the tool itself, we have the piercing unit. So this is like a small skid that's slid underneath the vehicle. It could be that if a vehicle's been modified or if it's lower for any reason that it needs to be slightly raised, but we can use a standard bar for pushing it underneath, and it's a pretty heavy little unit because obviously it's got to be able to withstand the impact that's going through it. But we have this pretty simple in terms of it's a spike that goes up. You can see the holes there that jet the water. I'm hoping this plays now. If it does it. No. John, do you know how to get it to play? Use the mouse then.
Display.
Oh, there you go. So it's simple. So as simple as that, and that happens in about 10 milliseconds for the deployment of it, because what we're aware of is that the spike itself has to go into the car as fast as possible. We don't want to go for a slow pierce into the vehicle. We need it to be as fast and responsive as possible. And we've got it here. If it works. There you go. And that's within 4 millimeters of steel, which pretty much is the standard that's used on the undercarriage of the car. So with the piercing tool, because it's pneumatically operated, there's no other sources that need to go through it, it's all provided, and we're getting an extension height of about 65 millimeters. We've done tests with Jaguar Land Rover where we've been looking at SUVs. Obviously, SUV style vehicles are a lot more popular. And what we found is that a lot of the SUVs that are on the market, the more the crossover style, they actually look like SUVs, but the height of the vehicle is no different to a standard car. It's only on the really extreme ones and sort of the proper 4x4 vehicles where we're having to use blocks or something like that just to raise it to go into the vehicle. So in terms of the suitability for it, we've had it tested on hybrid and electric vehicles. We've had it done with trucks where they have the batteries positioned on the underside of the frame. We've tested it on most current lithium-ion batteries that are on the market at the moment. And then the next step's the future testing. So the future plan is to test it on electric buses. My honest opinion, this kind of system's great when the car's on all fours. In terms of doing it on like electric buses, the batteries are in the roof. Will it be suitable for it in its current iteration? Probably not. We'll have to look for a redesign on how we do it and how we tackle these scenarios. We're looking at locomotives and we're looking at streetcars with batteries in them. We're looking at stationary storage as well. I want to tell you about some of the places where we've got these systems already within Europe. We're looking at stationary storage facilities because we know that not only EV fires are a problem, but also more and more green technology means that these battery storage locations are coming up, and how can we intervene into those? And solid state batteries as well is something that we're having to look at as a manufacturer. Currently, like I said, lithium-ion, as we all know, is the most commonly used, but we have to sort of predict for the future in terms of what other technologies could be used. So essentially, with the unit, in terms of the steps that you need to do, you've got to position the unit. The top left one there, as you're looking at it, is the conventional way that we would recommend to do it. We have done tests where we've tried to position it on cars that are on the side or upside down, but I've put these on because, in my opinion, the system's not suitable for these sort of scenarios. You can see there the types of bracings that's involved in terms of the forces required to pierce into the battery. So we include them because we tested it and we've done it as part of the R&D, but we want to be open and honest in terms of showing you the challenges that are involved with it. It's not simple to set that kind of system up when there's an EV vehicle fire going on. So in terms of your top left one there, when the vehicle's on R4, that's how we want to be positioning the piercing tool. Like I said, it's a two-step activation. The control system we've tried to do is as basic as possible. The gas cylinders just need to be opened. On the left there, we've got the switch, which is just a quick flick, which deploys the tool. Then we've got a venting tool on the button on the right, that vents the system ready for packing up and putting away. So, realistic scenarios. So, we accept and we know it is absolutely not feasible to outfit all frontline appliances with this kind of system. Like I said at the start, we are a manufacturer of fire trucks. We have to stow fire trucks on a daily basis. So when we talk about these systems, we don't expect our competitors to try and stow them within the vehicles because we know the challenges that would be within that. Our stance is that this tool is to be used in scenarios where unavoidable intervention is necessary. We're looking at the extreme situations where it's just not acceptable to not intervene. And we say that it should be used in conjunction with an EV fire blanket to protect the assets around it. So in terms of scenarios, car charging stations, they're cropping up more and more now, particularly around motorway services, where you're getting large numbers of charging ports where cars are going in and you're getting a build-up of electric vehicles parked closely together. Looking at transport vessels, ferries, these kind of situations where if there was an EV fire, it's okay for a lot of the guidance from say, yeah, let it burn, not a problem. That's the best thing to do because intervening. If you were on board a ferry and you knew that there was an EV fire going on within the car storage area of it, you might be 3 hours away from port. Is it really acceptable to just let the car burn? You need to do something about it, not just in terms of the fire, but you've got people on board, you've got the asset of the vessel, you've got other people's cars around it. Something has to be done and you need to intervene. Multi-storey car parks, underground car parks, again, you've got large structures, these cost money to do, you've got other people's cars within it, the cars are tightly packed because people try and squeeze more and more cars into these places. I know myself, I drive a pickup truck, I struggle to park that in some car parks, so I know how tight they can be. And as more and more of them become EV, you're going to end up with situations where you've got multiple of these vehicles parked together. Like I said, ferries is one of them. And also one of the things that we've highlighted, identified as talking to manufacturers is, they're producing these cars in their plants, but they're normally then shipped to storage facilities, normally around ports where you get a few thousand cars tightly packed together. If one of those vehicles was to go up, it's just not acceptable, again, to let it burn. We recommend using EV fire blankets to protect the assets around it, but it could be that further intervention's gone. One vehicle goes up, it's a problem. 2, 3, 4, 5, 10 vehicles go up without intervention, it's going to be a problem. And also scrapyards and quarantine centres. So there's been an RTC, the battery could be unstable. These vehicles are then being sent to scrapyards and they're expected to have the vehicle in quarantine for an indefinite period of time. If I was an owner of a company and I was being asked to take an unstable vehicle that's going to be stored there within my facility, I would want something that's going to be able to deal with that and intervene if there was a situation. So the key and the common thing between these scenarios is they are scenarios where the vehicles are on all four. Like I said, we completely accept that it is not like the silver bullet that was mentioned this morning. It's not the Swiss Army knife. It's for very, very specific scenarios where the vehicle's on all four and then you're looking at non-intervention being a completely unacceptable thing to do for it. So one of the things that we've had going into the R&D, and I'm actually glad that Paul brought it up this morning when he put it in, is some of the misinformation that's out there about our system. Like I said, we don't expect fire services to be investing in these directly themselves to try and outfit to the frontline appliances, but there has to be, and outside of everything that's gone on today, a two-way dialogue going on with these high-risk scenarios and the local authorities in terms of, okay, this is what we've got, this is how we can respond, and is there a way that they can work together? At the end of the day, they're trying to protect their assets. It should be there for them to invest in it, but the fire authorities should know that when they get there, there's something that they can do to and have to be used. So we're not trying to peddle this to the fire service to use. We're looking at high-risk scenarios and we're looking for the owners and the companies that have these high-risk scenario places to take a bit of ownership and to work with you guys for it. In terms of some of the stuff that went into the R&D for it, Paul this morning mentioned the Tesla test. So, it's a bit of an elephant in the room. I'm more than happy to address it. So the test scenario that he referred to was not done in conjunction with Tesla. We had way ago, we started the R&D projects that went into developing the tool, and trying to buy a battery pack from Tesla, because it is the most common EV vehicle on the market. It's near impossible to do. You can't just go into Tesla and say, can I have a battery pack? I'm going to experiment with it. They don't want to sell it to the open market. So we procured a battery pack that was already damaged to do tests on. When we were doing the preliminary R&D for this system, there's so much things we have to look at. We had to look at the force that was going into the piercing side of it. We had to look at the flow rates and the pressures that we were using. Do we use low pressure, high pressure, ultra high pressure? And like any R&D scenario, there were successes and there was failures. And in the particular one that he mentioned, we put too much water, too high of pressure within the battery pack. The pressure buildup was great. It went away and it got ahead of itself. And yep, there was a thermal runaway scenario. So, we have to address these things. And unfortunately, we have people that talk about our system who weren't there, who weren't part of the development side of it. And they then say, oh, yeah, this system here, and they like to put the picture of it up. It's not the system that we've got here today, which is UKCA and CE certified. It's approved for use. This is R&D elements of it that there was successes and there was failures. So in terms of the Tesla thing, one of the things that we quite commonly hear is a lot of vehicle manufacturers don't allow your tool, and that's also again misinformation. We've done a lot of research in the background and development with the vehicle manufacturers. Like I said, we actually supply these systems in Europe to the vehicle manufacturers. We have them at the Tesla Giga 4 factory in Berlin. We have them at Porsche Leipzig factory. We have them at VW Hanover. The Opel factory is part of the Stellantis group. We've got 3 factories within Germany, 1 in Poland, that have these systems on standby for exactly the scenarios that I've highlighted here. We have BMW in Austria, Ford in the USA, and VW in China. So one of the things that we do here, like I said a lot, is they don't allow this, they don't like it. So from our side of it is we say, okay, that's fine. So why are they buying them for their factories? They're taking the ownership, trying to protect their assets with the best tool that we've managed to develop at the moment. And one of the challenges then we have with that is they say, okay, these tools aren't allowed, they're not mandated. A lot of the emergency guides that are published by the manufacturers, they say, okay, it's not allowed to open the battery. We accept that, we know that it's not okay to open the battery. Rosenbauer is an Austrian business. 60% of our factory are firefighters. They are completely aware of the tactics that are involved with tackling fires. These guidelines, a lot of them were written in about 2016 before we had our system, and what they're referring to is your traditional Weber, Lucas, Holmatro extrication tools. And what they're saying is we don't want a firefighter going up, cutting the car up, trying to open the battery, because the next line within it, when they say don't open the battery, is actually the best method for doing it is to get water into the battery itself. So our advice and our philosophy when this was, okay, we're not going to open the battery, but putting a 20mm hole within the battery to get the water in has to be acceptable in certain scenarios, just like I said, for asset protection. And that's the way we go for it. So, the key point that I want you to take away from this is we completely accept this is not the silver bullet. We completely accept this is not the Swiss Army knife. We don't expect fire services to be purchasing these for frontline appliances. But this is, what we're developing now is about asset protection for situations, like I said, where intervention's unavoidable, where it's absolutely unacceptable to let it burn. And we encourage the use of EV blankets and to help protect the assets, and for the firefighters to use your experience and to use your knowledge to do what you think's best. But it's only through events like this that for us that we can sort of be open and as honest as we can about where we are in terms of our development with it. There are new iterations of the tools that are coming. We're working with Tesla because the new Model 3s are planned to have drop-down floor panels. If the drop-down floor panels are implemented by Tesla and then by other vehicle manufacturers, our tool will become completely obsolete, and that's absolutely fine for us because we can move on to the next R&D project in terms of how we address it. But at the moment, the vehicle manufacturers, like they highlighted this morning, aren't communicating to the best standards. So we have to address the most high-risk scenarios, which is where we are at the moment. The next tools will come out hopefully next year. They're in R&D phase at the moment. We're looking at ways of using a similar method for when the batteries are on the roof or on the side. But yeah, this is what I wanted to highlight for you guys, some of the challenges that we have, some of the misinformation, and if you want to take a look at the system, ask any questions on it, I'm more than happy to answer any reservations or any concerns that anyone might have. So thank you.
Afternoon, everybody. My name is Andy Coulton, Managing Director of Prosol UK. Excuse me. We are the inventors and producers of the Firecloak electric vehicle fire blanket. Basically, just want to give you a little bit of history about how that happened. So the company was formed in 1991. We primarily supplied the automotive aftermarket with a wide range of workshop tools and products. In 2016, I launched a range of EV safety products that included insulator tooling, safety gloves, insulator matting, a whole host of products. And the net result of that is that we're now regarded as one of the country's leading suppliers of this type of product. We have over 17,000 automotive customers throughout the UK. We supply many of the top 100 motor dealers, fast fit operators, the HIOWFRS, quick fits of this world, training companies that are particularly specific either to MOT training or EV training, which a lot are IMI accredited courses. We've supplied a good number of educational establishments, the colleges, again, that offer training, blue light organisations, such a lot of you people out there. It's a range that continuously evolves and is well accepted. So the development of Firecloak was basically an extension to our range of EV safety products. We were actually approached by Porsche dealers in 2021 when they released the new Taycan at that time. They very quickly identified that they had a problem with the batteries. There were a couple of close calls where vehicles were exhibiting the wrong kind of behaviour, and consequently Porsche put out a missive to all dealers that they should equip themselves with an EV fire blanket. So we researched the market for potential suppliers. We purchased through several companies that were already purporting to supply a product. And our first sale resulted in August 2021. That was selling a third party's product. We had issues with continuity of supply and also quality. As a result of that, I actually instigated a programme of getting in fabrics from the Far East, Europe, and we did some very, very simple tests, which was we'd actually stretch a piece of fabric in a frame and we put a butane burner against it. Now, 80% of those fabrics failed. So it just burnt a hole straight through the fabric. And as we went on this journey, we actually managed to identify a technical fabric manufacturer in West Yorkshire, close to Halifax. And with the feedback we got from them, the technical knowledge, they became our preferred supplier. We even went down to the fact that the amount of thread twist, the weave pattern, and different weights of fabric influence the overall performance of the product quite significantly. This culminated when we got the first prototypes going, and we've done some local testing, shall we say, not independent, just our own testing. And we did a demonstration at HIOWFRS, who I believe are represented here today, and he's waving at the back. And he was the man who was actually responsible for bolting the high amperage voltage that we applied to a Nissan Leaf. Might start crying a bit at the moment, but anyway, something that we had to burn. And it was just to prove the efficacy of the product in a real life situation. So on here is a short video somewhere. There we go. We towed it because the battery was disconnected, obviously. There he is. And thanks again to Warwickshire Fire Service, who assisted that day. So we put a high amperage charge into the battery to initiate thermal runaway. We did actually supplement that with a gas tank underneath to get the heat going. So you can see the firefighters a reasonable distance from the vehicle. The handles are quite long on the each four corners. Very rapidly, fire temperature drops to 47 degrees. As soon as you take it off, fire re-establishes itself. Now, of course, that's burning most of the plastics, interior components, but proved to be a successful demonstration of the product. No, you don't want to see that again. So, EV sales, you're probably all aware of this kind of information, but end of Jan 2024, over 1 million full electric cars and a further 600,000 plug-in hybrids. Worldwide, 14 million EVs being sold, representing a 35% year-on-year increase. Forecast to represent 86% of all vehicle sales by 2030. So all this goes through here is basically the stuff you've previously heard about, thermal runaway, what can instigate thermal runaway. I don't think there's any point in boring you much further with that. But the key thing is about the lithium oxide cathode, highly reactive, self-oxidizing, so the battery creates its own oxygen. And that is all parts of this process of thermal runaway. So all we're trying to do is to limit additional oxygen to feed the fire of the interior of the vehicle. So fire cloak, designed to contain is the key word, won't put out. Lithium battery electric vehicle and IC e-vehicles. The key point helps to prevent collateral damage to surrounding property and vehicles. So the fire blanket's role within the firefighting arena, we believe, is to buy time. So you can move other assets away from the scene of the fire if safe to do so. And that is our key mantra with regard to this product. Cost effective and easy to use. We control production. As I say, the fabric manufacturer, where we can go with that. So this is our fabric suppliers facility. Where have I lost the mouse? There she goes. So good old-fashioned looms, weaving away a variety of different technical fabrics. So it's just proving the point about our origins of products, etc. ISO 9001 accredited. So, independently tested. Only fire blanket in the world to achieve British standard Class 0 resistance to fire certification. This is where we started with the journey. Most people are aware of Class 0 fire doors, etc. So that's where we started. And that's an amalgamation of Part 6 and Part 7 of BS 476. That is a close equivalent to the American UL standard Class A rating. 4 weeks ago, we were down at Warrington Fire, and we did another BS 476 test, Part 20. It was an indicative test. And the fabric basically is stretched on a metal frame and then positioned in front of a furnace. The furnace goes up to 1,000 degrees centigrade. And after 90 minutes, our blanket was still intact. Now, the reason it's indicative is because if we want to get a full BS 476 rating, we have to do it on a huge 3 metre by 3 metre frame. And the 30-gram pill for that was a bit hard to swallow. So the indicative test is done on half scale, so it's 1.5 metre by 1.5 metre. We've gone for the European ISO 13501, which gave a rating of A2S1D0, which is all about fire resistance, how much the product itself is flammable. We did another US test, ASTM D6143, vertical flame resistant, so the open edge of the fabric is exposed to a continuous flame. And that passed with the highest possible rating. So char length, everything, resistance to flammability, all passed. And then another small test we did, the Federal Motor Vehicle Fire Safety Standard, which sounds very grand, but is not as demanding as most of the other tests that we've done. This will show you how we actually test various samples. This is a sample of the fire cloak fabric. So it's put in a little metal holding frame. It's not overly technical, just goes into a little fume cupboard. And then there's a platform that we just sit a propane burner on. We tried with the thermal imaging, but found it a lot easier with the infrared thermometer. So we got to a temperature of about 745 degrees C there, direct flame. Now this is quite an important part that, I mean, A, the fabric isn't compromised. You can put your hand at the other side of it. So one of the great benefits about the product is actually the fire insulation properties. So if you have got these other assets at the side of the vehicle covered in fire cloak, much less damage is likely to be caused. This is actually a slide from Emma Sutcliffe from the Australian EV fire that you saw earlier. Basically, we're just that is a sheet that they've actually produced, and we work with them, or we talk with them, have dialogue with them, and as we do with Paul Christiansen as well. So the whole point that we're trying to get across here is we're not just a marketing company selling another product. My background is from polymer chemistry, and I just like things to be so, much to the annoyance of most of the people that work with me. But so these are just some of the places, motor dealers. Again, we've supplied the majority of the AM100. A couple of months ago, we supplied the Penske Group, who are a massive motor dealer in the USA. And their modus operandi now is that if they have an EV in a workshop at night, they cover it with the fire cloak. And we're trying to get that message across to the UK market as well, because there have been notable main dealers actually go up in flames in the past 3 months. So against the cost of a fire blanket to a whole new showroom and workshop, I don't think there's any argument really. Charging stations we've had limited success with. But again, one of the things, the message that we're trying to get across is to the charging station guys, we're not expecting the general public to deploy one of these. And we say any suspicious, vape cloud or hissing, popping sounds, just go away from the vehicle. But what we're saying is, if there's a blanket there and the fire service come, they can deploy it. So we're trying to get a no-cost mantra across to some of these operators. So we'd hope that charging stations, just like petrol stations have to have fire extinguishers on the forecourt, why don't EV charging stations have to have a fire blanket on the wall? Car repairers, yeah, done. Car parks, we've done a good number of car parks now. Ferries, I would say 90% of operators, including the chain link ferry to from here to Purbeck, is it? I think it is. Yeah, they've got one. Recovery services, again, the guys taking these, not necessarily to deploy themselves on the vehicle when they attend the scene, but they're also a very, very effective product for actually putting over the vehicle when it's in quarantine. Because current knowledge is determining that there should be 15 metres between vehicles. Ain't going to happen. Nobody's got the land to do that. So that's our solution for that. Airports, we've sold to quite a few airports because they have a lot of pallet truck movers, that kind of thing, that are all lithium battery powered. Road tunnels, no. Shopping centres, we've sold a number now through Savills into a lot of shopping centres. They put them in the car parks where EV charging is. So what we're trying to do, we'll be building a data set of where Firecloak is installed so that any fire and rescue that will hopefully be able to log on to a database and go, oh, there's a fire blanket there. Good old boys from West Yorkshire. So the product range, standard one is 8 by 6 metres, certified fire resistance. We also do, it's when we visited our distributor in the USA, they all like driving small cars over there. So we do a 12 by 9 metre blanket as well, which particularly suits in the UK market, long wheelbase, high roof panel vans, which are starting to appear. Then we do an actual lithium battery blanket. This is made of a higher temperature resistance material because you don't get the cocooning effect of a car. So when the battery starts going, you don't get the direct temperature of the battery. You've got the whole vehicle cocooning that battery. And from our research, that temperature is a lot lower. So the high silica fabric is designed to be deployed direct onto a battery, maybe even a battery energy storage system, depending on the size of that. We do a range of storage solutions, and we've done a specific deployment guide, this with help of South Yorkshire Fire Service. So basically unfold centre in front of the vehicle, pull the red handles like the guy at the top is doing. The guy at the bottom hadn't listened to instruction. Tension the leading edge of the blanket, and you do tend to get a bit of a kite effect. So it isn't that you've got to drag it across the vehicle. You're almost creating an air cushion above the vehicle. Make sure it's centred on the vehicle. You can see a centre seam on there. We're now actually producing the blankets with an orange marker tab in the centre, both at the leading and the far edge. Tread down the edges of the fire cloak to remove any tunnels. When it's correctly positioned, get your standard hose nozzle, just crank it right back till you get that nice big fine mist spray. You don't want to be bashing it with water with a full stream. The reason that I mentioned about the water misting, what you're doing there is you're taking advantage of evaporative cooling, because as that water hits the blanket, the heat of the fire will drive it off. That actually works and cools the interior vehicle fire. The other advantage you have is you have no foul water runoff. Now you can maintain the fire like that ad infinitum. So when they say let it burn with a fire cloak. You might have a small response vehicle that may be like a 2+1 pickup truck, 300 litres of water on the back with a fine mist, fire cloak, done, sorted. And then you can get into inaccessible locations as well. So these are just thoughts, you know, they're not definitives. This is all part of this exercise of sharing knowledge. We often get asked if fire cloak is reusable. Yes, it is, if it's been used to contain a suspicious vehicle, or thermal imaging camera records that the battery temperature is rising above 50, 60 degrees C. As long as it doesn't burst into flames, yes, it's reusable. If it isn't, our view is that the contamination that is on that blanket, the heavy metals, cobalt, nickel, manganese, there'll be all sorts of PCBs on there from the fire itself. I'm sure a lot of you people know exactly what nasties are created, even an ICE vehicle fire. So, yeah, with a reusable, if you're going to be prepared to get it professionally cleaned, you probably have to reseal the high temperature silicon coating on it as well. And there is another key point. You've seen the batteries flying out of some of the cells flying out of those batteries on earlier presentations. You also have an issue with the hydraulic risers that are found in the back door, the bonnet, everything. When the fire temperature gets to a certain temperature, some of these things just fly through. I'm sure you've all experienced that with stuff just being ejected out of normal car fires. So there is a high propensity for the blanket to get holed by debris. So that's basically why we haven't gone down the route. We have got a product, but we are not launching it because we feel it's a false premise to think that you can keep reusing something like that. The biggest selling reusable blanket on the market at the moment is stitched with Kevlar coated stainless steel wire, which is the same as our blanket. They claimed that the blanket can withstand 2,500 degrees. It can, but the stitching can't. So it will fall apart. And they also mention it's been used on 30 fire tests. They set a vehicle on fire, and then they kept putting a fire inside that vehicle shell, and then put another fire in there. It wasn't an EV fire. And it's manufactured from carbon fibre, which is one of the most electrically conductive products on planet Earth. Why would you put that on an electric vehicle? Nobody has been electrocuted yet, by the way, but I've actually got a Kia EV6. That's 800 volts in there and 77 kilowatts. I wouldn't take the risk personally. And they're just a few of the leading brands. I'll just pick anybody from Formula E here. Good. Right. We can't publicise this. At the beginning of last season, they had to call the season off because they had a battery fire in the pit lane. They used our product to actually suppress that fire, and it saved the entire pit lane. So that's just a bit of anecdotal evidence about the product. You see Savills there for some of the estates.
Just mention Luton Airport as well.
No, I'm not going to do that. Yes, so actually, I've got to cover off Luton Airport. You're all aware of the huge car park fire they had. They actually ordered Firecloak 3 weeks previous. They had 40 blankets. They hadn't deployed them. They were still sitting in stores. So, might have saved a car park, that. Because they reckon the claim for that fire is going to probably run south of 30 million now. So, that's it. Thank you very much indeed for your attention. And if you've got any questions, fire away. Jeez. Yes, sir.
When you selling it to people and then the buyers have an expectation that the fire service is going to deploy it,
We're the only EV fire blanket manufacturer that actually supplies proper instructions for use. As far as what we've set as standard operating procedure, we can share that with everybody in this room and all fire services across the UK. You know, it's not precious. This is about a shared goal. Yeah, we're going to make some money along the way, but you know, at the same time, there is that ethos of let's make this safe as possible. Sure. Sure. Yeah. And then let them have a go. As I say, we train there. Yeah. So it is down to the providers. We provide you with a kit. Yep. And integrate with yeah. Well, as I say, it's a continuously evolving situation. As Paul Christiansen said, fire blankets do have a role to play. He hasn't got any applied knowledge of that. However, our Australian distributor is going to be hooking up with Emma Sutcliffe at EV Fire. And again, this is all part of this continuous learning that we can't do everything in a heartbeat.
Yeah, in motorsport, we deploy in the same way. We would have one or two in a paddock.
Sure.
But we'll only allow
trained fire marshals.
Because of the equipment, the clothing. The teams will carry them, and they are told that I will slap them if they start trying to use them.
Sure.
Because shorts and t-shirts, and this is got to be the same in
exactly. And we've done the same thing. So all the major motor groups that we've dealt with throughout the UK, we have gone and done physical training on site with each of the garages. Yes, sir.
Just wondering, when is it safe to take off?
To me, it's when it's burnt out.
And when's it burnt out? So
it could.
Just thinking you've
an average 70 kilowatt battery can take anything up to 3 hours.
Right. Okay. And just wondering, is there any risk with a vapor cloud explosion? Because you've kind of created an oxygen deficient environment, haven't you?
Yeah, but I suppose the thing about the vapor cloud explosions, one thing that we've seen firsthand is that when you deploy the blanket, we're trying to create an airtight seal, which also becomes, to a degree, a vapor cloud seal as well. However, one of the largest elements, when you saw the literature earlier, 50 to 80% of that vapor cloud is hydrogen. Hydrogen has an atomic number 1, and it actually leaches through the blanket. Now, we're actually going to do some proper testing so that we can quantify what that is. So if you're getting rid of one of the most explosive elements of the vapor cloud, then we think we're mitigating the risk there. But I stress the word think. And again, it is part and parcel of this whole development project has been about, let's get the numbers done. You know, let's prove to recognise standards that this does what we say it'll do. So whether that's full-scale testing under a large hood or whether it's scale testing and we just do something in the lab sort of thing, they're things that we're discussing and evaluating at the moment. Because we don't want to exacerbate a problem. With all that vapor cloud that's coming off there, we don't want that to get serious. Yeah.
Can I ask the cost?
You can.
Come and see it.
Oh, you want me to tell you?
Come and see it.
Depends on volume, but you're going to be just a bit north 600 quid. So on average, you might be at 690, somewhere around about there. Depends how many you want to buy. And again, that's supported price for blue light organisations. So we're not after making money out of people that are doing us service. That's the big argument.
Good afternoon. I'm going to introduce myself within the next slide, probably. I'm just discovering now I'm the first native English speaking person this day. So I apologize up front. I can talk Dutch to you, but you won't understand anything. So probably it's to do better not to talk Dutch to you, but to talk to you in my worst English. So that's what I'm trying to do today. My name is Frank. I'm working as a battalion chief in the fire service in the Netherlands. It's a part-time job. I also work at 2 companies, Total Safety Solutions, which are in the back, of course, and I have my own company, Art and Rescue Academy. We do mainly heavy rescue training in the Netherlands. I would also have a look at the TSS group. I don't know if you're familiar with the TSS group, but we started in 2019, and then we had, of course, the COVID. The founders of the TSS group invented the emergency plug. Maybe you're familiar with it. And in 2023, we founded TSS Learning because we thought we should not only make products, but also develop training. Because when you have a product and you don't know how to use it, it's not going to work. So products and training go hand in hand. That's our philosophy. In the next sheet, I will take you to my area, the area where I live in, where I do my work as a battalion chief. And this is my area. And when John invited me here, thanks for that, I was asking what I'm going to tell you. And I just asked myself, how safe is my playground? How safe is my area regarding to EV? I'm living in the area right here, Eindhoven. Last week we kicked out of the Champions League. Not very good, but yeah, you can have everything. The picture above is the economic growth for the Netherlands expected this year. And when you have a look at it, it's Dutch language, you cannot read it, but the bluer it gets, the more profit, the more economic growth we will get in that area. So you see the Amsterdam area is doing good, probably because you go there as a tourist. But the southern area, Eindhoven area, is also doing very good. And the question is, why are we doing so good? This is the answer. Because all the high-tech business is doing it around Eindhoven area. If I have a closer look at the automotive industry around Eindhoven area, you can see we have the DAF factory. They're now producing electric trucks, also going to produce hydrogen trucks. So that will be a big issue for us. We're not prepared for that one. We have 2 bus companies, eBusco producing in our area, but also VDL producing buses, electric buses, hydrogen buses in our area. Lightyear, it just got bankrupt, but good idea, also in our area. And this one is a very special one. What you see here is a big power unit. The regulations to build houses in the Netherlands are very strict. You have to have very high environmental issues. So it's not allowed to do it on diesel anymore. They use battery-powered equipment, and they use big batteries to refuel the equipment. That's how they do it. And then it was Christmas. And what happened at Christmas, you see one of the power units over here. The power unit, you see the picture here, is a big container, 20-foot container. It has a total weight of 30 tons, and it's filled with 27 tons of lithium ion. And it was on fire. It was on thermal runaway. You can see it on the picture here. And then we alarmed, we get to the scene, and they asked us, how are we going to solve this? The problem we have with EVs and with all the technology, we're always behind. So we come at the scene, there's a new technology, and we don't know shit about it, but we still have to handle the case. That's why the fire engine went there, they called an officer, the officer called the battalion chief, and nobody knows shit. So that's why we have like a WhatsApp group in the Netherlands with some smart people, and we asked our headquarters just put the message in on the WhatsApp group and give all the IDs that's made there, give them to us. One of the ideas was to put a big pile of sand on top of it. So lucky we didn't do that, because then we have created our own volcano for the next few days. Bad idea, but you know, it was some idea. Other idea was just keep hosing it with water. It would be a very big pollution, a lot of contained water. The idea what we run is this one. At the DAF factory, they produce electric trucks. They're prepared to submerge the electric truck when there's a problem. So they have a big container, this one, 100,000 liters of water, and we decided to put the container inside the container, submerge it, and solve the problem. You see the picture here? That didn't went very well, because the container, it broke down. And then we had 100,000 liters of water flowing around with all the pollution, but not only the big container with the thermal runaway, but completely submerged, completely filled with water. So the problem, in fact, we made it worse at the end of the story. This story makes me go to this thing. What we know is only just a little bit. What we don't know is a bigger part. That's why you came here today, probably. But at the end, there's still a much more bigger part. We don't know. We're never going to know all about it. And that's where we fill in the blanks at our company. We know solar panels can get on fire, boats can get on fire with electric cars, underground parking lots, you know, nothing special. So if you're at the fire brigade or ambulance service or police service, and you're not prepared for this, you're a bit behind. Or am I wrong? Okay, yeah? Behind or not behind? Yeah, agree or? I think when you know this and you see this ones, you're behind. So my goal of this presentation is make sure where are you now, where you want to be, and how you're going to make the step. And that's where total safety solutions fill in, because we have some solutions. We don't have all the solutions, we have some of them. We made solutions for electrocution, because not all the people are aware of the danger. We have a learning module, and we have the EV trainer, which is shown in the back. We also have the Stingray for thermal runaway, and we have, for unexpected movement, the emergency plug. Electrocution, just a small risk, but you need to know what you're doing. If you not know what you're doing, it's still a big risk. So you need knowledge. The level of knowledge and the level of understanding, that's going to help you. And on the other way, there's a lot of disinformation. When we talk to people on days like this, you know, things are a bit different than you thought before you entered this room today. So I hope this day will help you. What we also managed to create is a digital learning environment. We have multiple modules. This is the Dutch language, but it's already in English translated. Basic electric, because the firefighters, the new firefighters are training, also the firefighters from Amsterdam, the professional ones, and the new class, it's really stupid when you think of it. We got a new class of firefighters, and we do some training camp at the starting of the course. They all got a bike, start to cycle, they had a flat tire, and none of them, all 12, couldn't fix the tire. the flat tire. That's the people we get in today. I don't know if different in the UK, but that's how we start with new firefighters. In Amsterdam. Of course, in Eindhoven it's much better. So that's why we make a module basic electrics, because the firefighters we get in, they don't have all the knowledge about electrics. And we don't want to make them mechanics, but you know, high voltage, low voltage, AC, DC, some basics. I think you have to know when you're working on electric vehicles or solar panels or home batteries or whatever. We have modules like lithium ion, like electric cars, and if you need new models or you think we need to create new models, we follow the market, we follow your demands, of course. At the end, all modules, when you follow all the modules, you can do an exam, you can all do a digital, and the exam is according to the European standard, the 9140 standard, and it's a standard, a certification you need when you are working in Europe on an electrical vehicle. So it's we had the Brexit, of course, so maybe it's not applied to you, but in Europe, we had to follow the 9140 regulation. Then we have the EV trainer. We try to make the digital learning environment and the EV trainer combined into each other. So you have the option to follow only a digital course, you have the option to only follow physical course, and you have the blended learning. You can do the digital learning and the physical learning in combination. Another project we have, which is also good for the thermal runaway, enough on the thermal runaway so I can slip this slide, is the Stingray. The Stingray is produced by AVL, and do you know the company AVL? Doesn't ring any bells? No, it's one of the biggest automotive companies in the world. They work for almost every car manufacturer you can think of in the world. They do a lot of testing before producing a car goes into production. They do the testing. With all the testing of electric vehicles, they also face the same problem we did. Because when you're testing an electric car, you want to make sure safety is guaranteed. So that's why they developed the Stingray, and it's tested in a lot of cars already. I have a movie and you can show how it's working. AVL decided not to put it under the car, but put it in the car because the inside is much thinner material than the outside of the car. Another thing, you can place it anywhere. When you have a big set of straps, you can place it on a power unit, on a crane, on whatever you like. You strap it up, you hook it up, and you can use it. The other risk of EV cars is unexpected movement. This morning, Emma was already talking about immobilization, so make sure the car doesn't move anymore. Also, Phil was speaking about it. And this movie you already seen today. I will show it again.
It's the terrifying moment an SUV rolls over one of New York's bravest. It happened in busy Midtown Manhattan after a black BMW SUV crashed into a white sedan. A firefighter was trying to stabilize the BMW when a witness says the driver, who was trapped inside, accidentally hit the gas, causing the vehicle to come crashing down, crushing the firefighter's leg.
So when the impact on a car is very low, the safety system will not work. When the driver is still conscious, in fact, the firefighter followed procedure, went into the car, tried to remove the keys and put it in the park, and this happened. So that's why we invented something else. We have the emergency plug. The only thing the plug does is immobilize the vehicle. Nothing more, nothing less. That's all. So the only thing is you put a plug in and it's finished. It will not move anymore. How does it work? Quite simple, because every car in Europe has to follow the regulations, has to follow the R100 regulations, and that says it's not allowed to drive and charge at the same time. So when a cable is plugged in, the car will not move anymore. But when you put in a regular charging cable, probably communication will not always work. So it could work, but also could not work. So no guarantees. When you put in the plug, we put some smart software inside, which starts communicating with the car. It works 100%. When the color is blue, it's safe. It always works. One of our main products.
Safety first is the phrase we all know as first responders. But with the increasing number of electric vehicles, can we still guarantee a safe working environment? Unlike fuel-powered cars, electric vehicles can be deceptively quiet and hard to tell if it is still operational. If the car moves unintentionally, it can cause a dangerous situation. With more and more electric vehicles on the rise, it challenges first responders to know the status of the vehicle. Is it on or off? Due to multiple on and off methods, it makes it complex and time-consuming to quickly disable the electric vehicle. The emergency plug quickly prevents an EV from moving unexpectedly. Once plugged into the charging port, it simulates a charging process and switches gear from drive to neutral or park. The LED indicator provides first responders with real-time insight. Blue means it's safe for you. Green means no contact with the vehicle. Yellow means limited contact with the vehicle. Red means lost contact with the vehicle. The plug is universal, fits all electric cars, and can be easily plugged or removed at any time. All electric functions remain operational. Opening windows, adjusting the seats to create space, turn on the interior lights. With one simple plug-in action, you can prevent unexpected vehicle movement and safely disable electric vehicles. The emergency plug. Quick, simple, safe. Want to learn more about EV safety? Follow us on social media or visit our website at www.totalsafetysolutions.nl. The emergency plug.
The plug is not designed only for the fire brigade. It's designed for first responders. So also in the Netherlands, some regions, the ambulance service use it, police will use it. First we arrive on the scene, plug in, stop movement, and you can work safely. That's the idea. The goal of Total Safety Solutions is to make our work a lot more safe. That's our goal, and we try to do it with products and training. So that's a bit of the summary I want to tell you. Any questions? No questions? That clear? I wish it was the same at home.
Excellent.
Thank you very much.
Happy, John? Hi everyone, can you all hear me? Perfect. I'm Rob Barrow from Hampshire Isle Fire and Rescue Service. I'm the equivalent of John in our service. I'm the training lead. Been asked to come down by John today just to share sort of our training and our material of what we do back at home within service. A lot of stuff has been covered today, which I guess is good. One of my personal frustrations with this subject, and I mentioned it I think to our colleagues from the police, is the inconsistency across the country. What I would say is a lot of our information comes from the UKRO, which is the rescue organisation, which all of us can attend, where we attend really good CPD events, which will obviously help increase our knowledge out on the roadside and to help those people that we have to go and rescue. So today's mainly looked so far around electric vehicles and the actual vehicle as being a hazard. What I'm going to do, I'm going to start my presentation just by quickly looking at the infrastructure and how I believe that is something that's being overlooked into our actions when we turn up to these incidents that we need to resolve. So the picture on the left is a city sort of environment where we've got e-scooters that are on charge in a public area in our community. So ourselves back at home in Southampton and Portsmouth, we have e-scooters everywhere. We've got two different sort of systems in play. In Portsmouth, the e-scooters go to a central point. Someone goes round in a van, they collect those scooters up and they take them away to be charged. In Southampton, we have a mixture of the two. We have some which are dedicated charging points where the lead goes into the scooter in a dock like that, or again, they get collected by someone in the van and they get charged. So my question to you is, it's 2 o'clock in the morning, we've got an LGV that strikes this road furniture. How do we isolate or ensure that that e-scooter charging point is isolated? Someone answer.
Wake somebody up.
Okay, the reality is we don't know. Okay, so when we assess and we're looking at the scene now, it's not just the actual electric vehicles, it's the infrastructure that supports those vehicles that could be a problem for us as an emergency service attending. The answer might be that that building behind it is where the isolation is for that scooter bank. It might be that it's a substation in the ground, or it might be we have to get the electricity board out to come and dig up the road to actually make that safe for us. The unknown is where we're at the moment. To get around that in service, what we're doing as part of our risk information, our risk collection, is if we identify that the premise has scooter charging or e-charging, we collect that information and we record that on our risk information that we can make available to our crews when they arrive. Okay. The picture on the right, this is a European picture, but it will come into the UK at some point. This is I always use a Deliveroo driver as the example. It's an e-scooter with, let's say a 50-mile range. They go around in their scooter, they run out of battery, they take the battery out of the scooter, they put that battery into a charging bank, they take another one, and off they go. There's their 50-mile range instantly. The same principle. What do we do for that car that's driven into that building? Or we now attend a fire in that building. How do we confirm that that fire loading has been identified? And how do we identify how we isolate it? Okay, it's just awareness, guys, but it's something else we need to think about that supports these electric vehicles. I live in Winchester. We have lamppost charging. Have any of you seen that? Come across that? Oh, yes. Okay. Lamppost charging is becoming very, very common, particularly in areas where there are permit parking, and particularly because you can't run an extension lead from your house across a private or public area. So they use the lampposts. We now have 230 volt at waist height. So again, if we turn up to a road traffic collision where we've got a car versus road furniture, it's now actually to identify, is that a charging point? And again, how do we isolate that lamppost, which we need to do because we've obviously got a high voltage there that could be a risk. Okay. On the left here, down the left, the charging points. Okay. Does anyone know how we would isolate those? If we turn up to a car park, we need to make a fire break. Okay, the switches are not on the charging points. Okay, so they normally go back to a central board or they go back to the building. But again, it's about understanding that information, and if we can gather that information prior to the emergency, that's going to be useful for the day we actually attend those incidents. Okay. Bollard parking or bollard charging, sorry. In Southampton, we've got that. In Portsmouth, for some reason, it's been U-turned. I don't know why, but they're no longer installing that as an option. But when you look at that, you wouldn't expect there to be 230 volts, would you, at waist height, okay? Particularly when you've got a car that's done 50, that's ripped that out of the ground following a collision. My next point is the picture up here on the top right. When we turn up to an electric vehicle fire on someone's drive, we might put some BA teams into the building to isolate the electric. Traditionally, where do we isolate the electric from? From the fuse board, isn't it? The consumer unit. Most people, when they have an electric charging point installed in their property, don't have enough room in their fuse board, in their consumer unit, to actually have the breaker put in. To have a new fuse board is going to cost them almost double the price of the actual charging point and a new fuse board. So what the electricians do, they take an additional breaker off the tails, which is separate, which supplies the charging point independently. Does that all make sense? So if you're briefing your BA team to go and isolate, make sure we get that information to understand actually how we isolate the charging point. It might not be the traditional breaker on the fuse board. It might be its own dedicated supply. Okay, the reason I'm sharing that with you is after some learning after a recent incident ourselves back in service. Okay, everyone all right with that? It's gone really quiet, please talk to me. So other infrastructure then, forklift trucks, yeah, they're becoming sort of lithium ion. We had an incident a few weeks ago over on the Howe Mills estate in Basingstoke. We went for a fire blanket tactic with an RSV winch to actually remove the forklift from the premise. Okay, so fire blankets, I'll talk about them a little bit more later on. we're also starting to record if the premise has a fire blanket on our risk information. So when we get to the incident, we can look at our SSRI or op prompt, and we can then obviously determine if we're going to use that blanket as a firefighting action. JCBs, okay, I don't know the emission-free areas sort of around here, but in Portsmouth, we've got lots of zero-emission areas now. So we're starting to see that the builders are having to use zero-emission electric diggers on the building site. And again, it's just that awareness that when we turn up, traditionally what we think of an EV, we mainly think of a Tesla. It's expanding, okay? It's now our construction vehicles that are becoming pure electric, running off a lithium-ion battery, okay? Double-decker buses, someone said this morning about the batteries being in the roof. On this particular bus, they're at the back, and then they go down and underneath. However, the charging for this double-decker bus on the image on the left is through the roof. Okay, so this is a London bus, goes into a side depot, the charging cables come down, and that charges the bus. Again, awareness for when we're turning up to an incident where maybe the charging facility has been damaged. It's something else that we need to consider now and make sure is isolated if we attend that incident or is involved. Cool. Okay. So electric vehicles then, it's been said throughout the day, more and more of them on the road in the UK. As a service, we went for a spell of having none, and then we had about 3 within 4 weeks. And we've also had a theme recently of forklifts, where we started to see an increase in that call volume. So we are definitely starting to go to more of these incidents. Does anyone have a guess at what our average in attendance time has been at an electric vehicle fire? What do we reckon? 18 hours is our top one so far. So we've had a fire and rescue service resource in attendance for 18 hours, okay? And that's been mainly around a battery that's caught fire, been damaged, and just for whatever reason, we can't get on top of it to be able to put it out, etc., etc., okay? I'll skip the history. So I think it's really important to understand, and the way that our training within service is done is that we treat a hybrid vehicle and an electric vehicle the same in relation to hazards and control measures, okay? So a hybrid vehicle, even though we have a combustible engine up in the front, we have somewhere within that vehicle a battery and high voltage systems. The hazards are the same or presented are the same to that as an electric car. So when we teach this training to our firefighters, we get them to basically treat them both as the same sort of vehicle type, okay? So we've done a lot of this throughout the day, so I'll skip through. So we spoke about the hazards throughout the day, and different people from different organisations have mentioned those hazards. As a fire and rescue service, any idea what the 4 main hazards are us when we're attending a road traffic collision with a vehicle which is damaged? What are the main 4 that are going to hurt us, do you reckon? Electrocutions, we've got high voltage risk. Silent running, so we've got potential movement. Vapor cloud, so gas is produced from a damaged battery. And the last one, fire, which comes from the gas. Okay, it's uneven weight distribution and added weight to the vehicle. So what we're going to talk about in a minute is about a Tesla on its roof, and if you would cut the B post out to be able to do a side removal. Okay, and I'll show you some images that will probably make you not want to do that. Okay. There are loads of others, but when we deliver that training for an extrication purposes, they're the 4 main hazards that we want to ensure that our control measures are in play for. So on a Nissan Leaf, this is an older model, we've got just under 300 kilos of batteries in the floor pan. Traditionally, most cars, 60 to 80 litres of petrol or diesel, we're nowhere near that weight in the floor pan, are we? So when we throw an EV on its roof, how's it likely to sit? Nose down or maybe on the roof? Yeah, it's going to be on the roof, okay? So straight away, due to that added weight and the evenly distribution of batteries, we're going to have that issue when we come on to stabilise and extricate. Anything orange denotes high voltage. So if we're seeing orange cables when we attend that incident, that is not a good sign, yeah? That tells us that that vehicle has been in a severe collision and the risk of thermal runaway is actually quite high, okay? So this is everything the IAIM or the IAIM that we followed throughout the day, we do exactly the same within service. I've just broken it down to actually go into a little bit more detail on how we start the identification. So identification for us, if the call comes into the control room within Hampshire Isle of Wight, that is when the identification process starts. Our fire control operators will ask the caller do they know the propulsion type? Do they know if it's electric? Do they know if it's a hybrid? They will also ascertain the number plate, and they will ask the question around, does it have a green number plate? Yes or no. We know that's not an MOT requirement, but if they're telling us there's a green checker on the number plate, then we know that that vehicle's electric. Okay? So we start that identification phase before we've even mobilised our resources, or if we get further information, we'll update them en route to the incident. Okay? We then, when we arrive in attendance at the incident, is we need to identify the collision category. To keep it really simple, like collision, no airbags have gone off. And as our colleagues from the police said, that vehicle is still potentially live. Okay, the airbags have not operated, the little pyro fuse hasn't activated, so there's a good chance for that vehicle, if someone does touch the accelerator and it's in drive, it will run away. Okay. If the airbags have gone off, and that is another question that is asked at time of call by our 999 call handlers, is that the airbags have gone off. Hopefully, if the vehicle has done what it's meant to do, then the high voltage side, the low voltage side of the high voltage should already be isolated. But as again we discussed earlier, we can't take that for granted. Okay. The severe category is that the caller is describing they can see orange cabling, or the vehicle is venting or gassing. The question though is, do the members of the public know the difference between airbag residue and an EV gassing off? Probably not. Okay. The telltales are though, if airbags have gone off, the residue will be in the car. Most times when an EV vents, it's from the outside of the vehicle. Okay. When we get to the incident, we're going to approach from the sides and we're going to chock all four wheels as a default, and then we're going to use our crash recovery software, which I'm going to show you in a minute, which is number plate recognition, to tell us how we deactivate that vehicle. The service is invested from the 1st of April that all of our frontline appliances will have that software on our removable data terminals. So at the incident, we can put the reg in and it will tell us everything about that car. And I'll run through some examples of that in a minute. Do any of you use CRS? Cool. I'm not going too quick, by the way. We're all right. It's really quiet. I don't like this. So once we've identified the deactivation information, we're then going to deactivate the vehicle as per the information provided by the vehicle manufacturer through our software, which is available in the appliance. What's really good with the software is it doesn't rely on airwave, it doesn't rely on 4G like SIM card signal. It's downloaded onto the tablet at the station when the vehicles are on station. Okay, so it's constantly updated. We're not going to cut or touch any high voltage components. We're not going to, and we're going to ram and spread with caution. So I've already said it. Where are the batteries in an EV? Floor pan. So if we've got a casualty that's trapped by the dashboard, traditionally, if there's nothing in front of the vehicle, what method would we go for as an extrication? Dashboard relocation or dashboard roll. What happens, or what can happen to the floor pan when we do a dashboard relocation or a dashboard roll? Yeah, it can rip or move, can't it? So we would opt to go for a dashboard lift instead. So all the forces now go through the sill and the A-post to minimise any disruption to the floor pan where we know that the batteries are. Particularly if we're extricating someone who's physically trapped, the vehicle's probably already been through some impact. So there's a likelihood that those batteries might already be damaged. Does that all make sense? Cool. If we are spreading for whatever reason, we don't want to put a ram on the floor pan. On our RSVs, our heavy rescue vehicles, we've got 4x4 timber. We'll drop them in and we'll try and brace the gaps between the two seals to try and ensure that our forces are being pushed through the seals, not directly into the floor pan with the batteries underneath them. Okay. We are not going to drill into the undercarriage of the vehicle. So traditionally on a car, petrol car, diesel car, we've got little knockouts, haven't we, that we can knock out to put our stab fast hooks in. On an EV, I'll show you an image in a minute, it's a solid undercarriage. The last thing we want to do is be drilling a hole, okay, through that 4 mil of steel into the batteries, because that's going to cause us a further issue. So straight away, stability could be a problem. We're only going to lift the vehicle on the dedicated jacking points, okay? So a lot of Teslas have like an air hockey puck that you put into the dedicated jacking point that spreads the load. If we're putting spreaders under the vehicle to maybe extricate someone who's underneath them because the vehicles are silent running, we need to be really careful where we're putting those spreaders. Okay, yes mate.
Do you have the same issue with, we use high pressure air mats as well?
Yeah.
Yeah, so.
Airbags, ours are really big. Like,
yeah,
so,
large ones as well.
They'll be fine.
They're fine.
Yeah, so if you imagine your spreaders, the tips of your spreaders are really sharp, aren't they?
Yeah.
And what we don't want to risk is the sharp spreader tips going into the battery, or we cross-load it and we actually damage the battery further. with an airlifting mat, it's a much wider
Yeah.
surface area.
Surface
and we're going to be a
area,
lot safer.
yeah. Perfect.
All right. We're then going to consider our gas monitoring. So gas monitor will go in the car and around the car. Okay, so we'll have 2 gas monitors in play with a view that as soon as one starts alarming, that's BA instantly. We spoke this morning around what we do to a casualty. We as a service will put a casualty in a BA set. Yeah, if we need to, we can't get them out at that moment in time. Clearly, if we can do an emergency extrication and drag them out, we're going to do that. If we can't, we'll put them in a BA set until we can make that space to release their legs, etc., to get them out as quick as possible. Okay? We're going to monitor the EV with a thermal imaging camera, identifying the undercarriage if we can. And if we get any temperature above 60 degrees, even if there's no other signs of thermal runaway, we will commence cooling. Okay, and that is done at the moment with a fan spray that just goes straight under the undercarriage to provide water, as we've spoken about all day, seems to be the best thing for cooling, to start that cooling process. Okay. We will have a upgraded SING safety, so we will have a 45mm jet laid out for a hybrid or a electric vehicle incident. The 45mm jet is not for the car. What do we think it's for? How far earlier on in some of those films were those flames going? Yeah, so if we suddenly get a thermal event, the 45mm jet is there to be able to prevent that fire from spreading into another vehicle, a garden fence, whatever that looks like. Okay, so the covering jet isn't for the car, it's to provide adequate water to around the vehicle if it does start to go into full thermal runaway. And the other thing we'll start to do, and hopefully a cross-border working, this will start to happen, is we will start to record the temperatures of the vehicle on every informative message. We recently had an incident where we were in attendance for 18 hours and we didn't have one temperature recording on any of those messages. At the end of the incident, when we wanted to hand the incident over, we couldn't actually tell the recovery the difference of temperature. So what we want to do is we want to ensure that we turn up, it's, I don't know, 100 degrees, we put that on our first informative. When our stop comes in 12 hours later or whatever that looks like, we can show on log that we've actually done some cooling and we've got a significant temperature difference. Does that all make sense? Hopefully you're all doing that anyway. This is what we're doing in service. Any questions so far, guys? No? Cool. So we've already spoke about approach from the side. We're going to do that. We're going to chock all 4 wheels. And again, we're going to operate any first responder loops as soon as possible. We carry 2 wheel chocks on all of our frontline appliances. We also carry 4 wedges. So if it's a 1 pump attendance, this is how we will chock the 3rd and 4th wheel by utilising 2 wedges, 1 in and then another one into the back of it. Okay, that's what we're going to go for as an initial attack. As soon as the 2nd pump gets there, if it's only 1 vehicle involved, we'll potentially change over our wedges for an actual caravan chock or caravan chock, which is designed to obviously stop the wheels. Again, echoing what everyone has said today, in testing, we're quite fortunate. We have a lot of electric vehicles in our pool vehicles that we can hire out for training. We block all 4 wheels, we chuck someone in the car, we hit the accelerator, it jumps straight over the 4. Okay, however, it slows it down enough to be able to get one of you hopefully out of the way if you were in that stage of obviously doing the isolation. Okay. The last little bit as well is something that we'll encourage everyone to do for paramedics amongst us, the police amongst us. Has anyone got an electric handbrake on their car? Yeah? So when you're stationary and you open the door, what will happen to your handbrake? It comes on, okay? So what we don't want to do as paramedics, as firefighters, we don't want to lean through windows to cars, okay? So our initial tactic will be open the driver's door, the vehicle stationary, hopefully the handbrake will come on, okay? If it hasn't come on, then it moves. Most people crash going forwards, it's going to go away from us. What we don't want to do is put ourselves through an open window, the car starts to move and now we're going with it. Okay? Does that all kind of make sense? So, petrol Golf, 1,665 kilos. Okay? Myself, I worked at Winchester and Basingstoke, both SEU stations, been to a lot of Golfs involved in collisions. From my experience, Golfs actually do pretty well. Yeah? Okay? They're pretty solid old cars. How much do we reckon the electric Golf weighs?
1,000.
Just over 2 tonne. Okay, now I'm no mathematician, but I've been to an incident involving a 1,600 kilo Golf, probably doing 70 mile an hour into a tree, and that's not very good, is it? We've now got 2 tonne of car potentially hitting a tree at 70 mile an hour. So that mechanism of injury or the impact that that patient's gone through, even though that car might be built better, is obviously the energy is going to be a lot more. The biggest concern is when we now get a 2-ton Golf hit a 1,600 kilo normal car. What's going to happen? What's the damage going to be to that lighter vehicle out there? The latest Teslas weigh just under 3 ton. That's a lot of weight, okay? And it's something that we need to consider in the stages of maybe our resources to ensure we've got the right vehicles going to be able to resolve those incidents when we get there. So how much can a new driver in terms of weight drive on their car licence? 3.5 tonne, okay? So a new driver can drive 3.5 tonne conventional vehicle, yeah? Petrol, diesel. What the DVLA have done, because these vans that are pure electric were weighing just under 3.5 tonne without their payload. So when you put your 800 kilo payload on, these vehicles are weighing more than what you can drive on your car licence. So what you can do, you can apply to the DVLA, do an online course, and you can now drive 4,250 kilos on your car licence. So those Sprinter vans, those EPD vans that are running around now weigh just over 4 tonne. When you look at Stabfast as an example, with a 1,500 or 1,700 kilo capacity, you know, in terms of its capability, you're right on your limit, aren't you, if you've got one of them on your side and you need to stabilise. So these vans, what we've done in service is we've started to treat those as basically an HGV job. So we'll try and mobilise our heavy vehicle to anything involving an electric van due to those added weights involved in the impact. Okay. Guys, any questions so far? Hate it. It's all one-way traffic. I hate it. But so this is just to give you an example of the vehicle collision categories of how we assess that. So the first one on the left being no airbags have gone off. That is the most dangerous to us on approach because that vehicle is still live. Okay, and we need to chop the wheels and immobilise, deactivate that vehicle as soon as practically possible. The medium collision is an airbag is activated, it's light bodywork damage, maybe the shut lines are compressed, but the airbags have activated. And then our severe is we can see orange components, okay, and the likelihood of thermal runaway is high because the battery has probably been damaged. That's how we identify that, and again, that is based on guidance from the UKRO, which hopefully is being rolled out to all those services who attend those events. So here we've got a Tesla on its roof, okay, not up against anything, on its roof. We've got a big old weight of battery in the top there. Can you see that the undercarriage is solid? There's nowhere to put your Stabfast hooks or your Paratech hooks, yeah? These here are the jacking points. Normally, there's like a plastic that goes over that, so you wouldn't actually see where they are, okay? So if that vehicle was on its side, your stability might be limited. You might have to go back to old school, short X and ratchets, okay, into the wheels, or actually put your Paratech with Stabfast onto the subframe of the car, maybe use a J-link or something like that as a suitable anchor to be able to make that vehicle nice and safe. We can see though that actually the car itself, even though it's been in a severe collision and it's been fully involved in fire, it's actually held out quite well, hasn't it? The shell's done really well. My question to all of you though, is what if we take that B-post out?
It goes down.
It's probably going down, isn't it? So it's just around that understanding and the communication to our friends in the ambulance service, our doctors, etc., that the space you've had in the past for a car on its roof, if it's an EV, we're not going to give you that amount of space. We're not going to risk the chance of that floor pan giving, then damaging the batteries, okay? We'll just make sure we won't give you as much space. We'll look at maybe tunnelling, something like that, but the casualty's going to have to come out of smaller space than you're used to. Does that all make sense? Cool. Yeah, we don't want to remove it. So, converted electric cars. Has anyone got a converted electric car? Anyone done it? No, considering doing it? Okay, it's quite scary. It's actually a bit of a thing in the UK. We've got a company just outside Rushmore near Farnborough. That's their full-time business. They take in classic cars and they convert them with recycled lithium batteries to make them pure electric. Okay. Those vehicles then might have no recognition that they're electric. So all three of those are converted electric vehicles. Was the transporter on the left or the VW camper built to have a battery of maybe 400 kilos inside it? Probably not. Jack Williams, who used to be in the role before me, before Jack retired, we both went to a converted electric sort of cinema event. They showed us a camper like that. They opened the back door. Batteries were ratcheted into the floor pan. Okay. What a lot of the companies do is they build a false floor and the batteries go inside that. But if you turn up at 2 o'clock in the morning to that, I'm pretty confident that we'd all think they're petrol, right? Okay, so it's just that recognition, that understanding. What's really positive is when the vehicles are converted to electric, the DVLA are informed, and if you use the software that we've got on our appliances, when you type in that reg, it won't tell us any information on how to deactivate, but it tells us that vehicle is registered as electric. So it's another tool that we can just know straight away that we're dealing with an electric vehicle, and it's probably converted. So we spoke about these throughout the day. Cut loops, okay, and we'll go into this in a bit more detail shortly. Becoming quite common now in most vehicles. Our French manufacturers, they've gone for a gallet. Okay, so it's an American fire helmet on most cars. Our Corsas, our Renaults, etc. Sorry, our Vauxhalls, they've gone for a gallet helmet. That's their recognition, okay? But again, if we have the software available, we can utilise that software to be able to determine how we isolate that vehicle. And as our colleagues from the police said earlier on, the isolation points are changing, yeah? Some are little pull fuses, some are cut loops, some are little fuses themselves. We will, with the right safety measures in place, isolate on the high voltage side. So the software we have tells us how to do that safely, and we ensure we provide our teams with electrical gloves to do that safely. Okay? You might not have access to any of these. The car's wrapped around a tree, and the only point you've got is to pull the main plug on the Renault Zoe in the footwell, for argument's sake. That's what we would do. But we would ensure that our control measures are in play before we do that. Does that all make sense? Gas monitoring then, as Paul said this morning, loads of gases are released. Okay, these are the 4 sort of main ones. We're going to put that gas monitor in the vehicle and around the vehicle. Okay, if we're attending an EV on fire in a car park, we should be having that gas monitor and RBA teams as soon as we enter, yeah, or even us in normal wear to start to be able to monitor those gas levels if we know it's a confirmed EV or hybrid vehicle in a car park undercover, for argument's sake. Cool. So a little film to watch. What I want you to look at, we use this case study or this film with our fire control. This is obviously a broad film, but what you've got is you've got an electric car on here, which is on charge, an electric sort of hybrid van, small lorry, and then 2 further electric vehicles on charge. It's a 4-minute film. I want you to look at the speed of fire development, but the biggest thing I want you to take away is the noise, the hissing noise, which is a sense that we need to use before this vehicle actually goes into thermal runaway. Hopefully the sound will be all right, John. Okay, so can we all hear that sort of noise in the background? That's nothing at the moment. In a minute, the way it's been described to me is like a jet engine of an aeroplane about to take off, and this film will kind of give you that sense. Okay? So you can see on the right, nothing's really going on. Okay, you start to hear that noise now, that increasing noise. So we share this with our fire control. If they can hear that in the back of the pool, they're telling people to get out of the way. Yeah, move away. So we've now got visible gases. And you'll really start to hear this noise kick in a second. Starting to build up. Boom, there it is. And again, a really aggressive fire, a rapid changing fire. If this is in the middle of nowhere, we're probably not even being called yet, have we, as an emergency service? And we can see that is a significant flame coming from the rear of the vehicle. What you'll notice is the lorry's about to move. That's because the handbrake cable is burned through, so we've now got a moving hazard. Okay, we've got a lorry that's about to be on fire, which is about to move. And if you look in the background, there's a load of forklift trucks over there. There's not someone moving it, that's the handbrake cable. So we're probably starting to receive some calls now. So if you think about the impact on our control rooms, the amount of calls they're going to be receiving, probably a lot of panic. So what we'll end up with very quickly, if you keep an eye on the car on the left, the back end is just starting to go. And as we described earlier on, the vehicle fire here is definitely battery related. These two are not, but they probably will be due to the extremes and the heat that are being presented. We're probably not even mobilised, are we? Maybe? So we can see just over 2 minutes the amount of damage that's been created, yeah? And this is in an open air car park. Imagine if this was under a shopping centre or in a hospital multi-storey car park. Okay? Cool. I'm going to move it on, but basically we end up with all four going in 4 minutes. Okay? Oh, hello. Right. Okay, so what I'm going to share with you now is just something around an incident, and again, some instant learning that we have within Hampshire and the Isle of Wight. There are no injuries before I play this film, okay? Everyone walked away, everyone was okay. The driver, it is mooted, but he does swear, so I'm apologising in advance, okay? And when you see the footage, you'll probably understand why. So in Southampton, we are one of the major ports of Tesla and electric vehicles. We currently have between 10 and 12,000 electric vehicles in the docks, ready for distribution either into the country or back into Europe. Okay, so we know we have that hazard on our fireground, as it were, but we also have the M3, the M27 going up to the M3 going up to the M25, A34, etc., where we have Teslas on lorry transporters daily, yeah, going out the docks into different parts of the country. What we've got, you can just see ahead up here, is we've got a vehicle transporter carrying 7 Teslas on its way north. The driver has a blowout and he ends up on the other side of the carriageway. The reason I'm sharing this footage with you is to highlight the damage caused to an EV where the VV was just on the loader, yeah? It wasn't doing 100 mile an hour or 90 mile an hour. And we'll play it and we'll give it a go.
What are you doing this evening when you left the school? I can't tell you that because you'd expect the question and how does that affect?
I don't know, did anyone attend this from highways or anything like that? Police colleagues aware of it? There's no one injured, luckily. I'm not sure how, but there was a significant amount of learning from this incident for us.
That weight that was put behind it was gas powered as well.
Was it? So, this is one of the Teslas that the crew turned up to. Okay, the wheel set for the car in the left is here. Okay, please take note of the turf or winch set up to that car, which was done by our crews. Remember that for in a minute. Is it fair to say that that is severe impact collision? Yeah, the fact we have orange cables exposed. So for us, that is thermal imaging, covering jet, gas monitoring. However, there's no life risk of causing that vehicle by moving it to go into its thermal state when it's clearly been involved in a significant severe collision. We would stay on scene, we'd have our control measures in play, and we would make sure that we're there until recovery get there and ensure that that vehicle was recovered safely and effectively. Okay? I don't know, would anyone move it? Probably would have, but it might not be the best thing to do. Okay? Fire blankets. So we have fire blankets within the service. We have 4 fire blankets on our heavy rescue vehicles scattered around the county and on the Isle of Wight. We also have awareness training for all our crews. So what we're finding is a lot of our buildings now, a lot of our premises, they have vehicle fire blankets on site. There was a question asked, well, if a member of public's deployed one prior to our arrival, what do we do? So we've come up with some training, looked at some guidance on how we're gonna use those blankets, either if they're on the wall and available for us to use when we get in attendance, or if someone's put those vehicles in use prior to our arrival. But also we carry them on our RSVs as a tactical option. As the manufacturer said earlier on, we're probably not going to use a fire blanket on a fully involved vehicle. We would probably use it as a fire break, or we would use it as a suppression measure to buy us a window of time to create space, make a break, rescue people from houses, etc., etc. The only thing differently, and a couple of people were talking about it over lunch, is around when do we remove the fire blanket. So as a service, we have decided to go for a fire blanket tactic where we will also utilise water, and we will put a fan spray under the vehicle, and that will cool any unignited or ignited fire gases that are underneath the blanket. We will then have 4 BA wearers for the removal phase. We'll have 2 BA wearers stood by on a hose reel and a jet, and we'll have the 2 BA wearers that actually remove the blanket from the vehicle. If, when they're removing the vehicle starts to flare up, we've got 2 hose reels or a hose reel and a jet in play to be able to start suppressing that fire and provide protection to those removing it. Or the other tactic is we just recover the vehicle. Okay? We will probably not remove the vehicle until we're getting temperatures of less than 40 degrees on our thermal imaging cameras. Obviously, someone will have to go underneath the blanket to get a true reading. Through the blanket, it's not going to be that accurate. So that's what we've gone for, and we're more than happy to share all that training material with anyone if they want it. Okay, let's not reinvent the wheel. We're pretty good at that in fire service, aren't we? So this was a job that we had out in Borden, middle of the day. Occupiers were at home. No one was in. No occupiers in the house involved. Next door, the occupiers were at home. They heard the hissing. They saw a little bit of sort of gas, and they phoned the vehicle through as a vehicle fire. Following the recent incidents, we've increased our response plan. So off the bat now for an EV or hybrid vehicle fire is 2 appliances and the nearest FDS officer, and at time of call, a hazmat officer is also informed. That comes from learning from incidences that we attended earlier in the year or last year. In this scenario, if that was 2 o'clock in the morning and that vehicle's well alight and we had occupants in that house, this is where the fire blanket would have been really useful. We could have thrown the blanket over the car and actually done our rescues from the house, put the fire out, etc., etc. Okay, so they absolutely have their places. Cool. John mentioned this morning. We will always do a handover sticker for any vehicle incident related incident we go to. So even if it's a car leaking fuel, yeah, we'll put a handover sticker on it and say we've done X, Y, and Z. Okay, and that's just highlighting to recovery, forensics, whoever, this is what we've done as a fire and rescue service. We will also, if we have operated any of the first responder cut loops or fuses, we will put them on the windscreen, okay, by the windscreen wiper, as that appears to be recognised practice of where people look for that isolation information. Okay. Everyone got handover stickers? Cool. Etienne, you've advanced it, your team, haven't we? So we're now having one with a table with thermal imaging temperatures that we stick on the car. So it'll be time 10:02, 90 degrees. Yeah, and we stick that on the car at point of handover so we can confirm the time we were in attendance. We checked the temperatures for this range of time and they were X, Y, and Z. Cool. Any questions?
One quick one.
Yeah.
You said about the vehicle modification for like the camp vans and stuff like that. Do they have to legally put in
So from what we've done in service, and like we've worked with the local company, it's quite scary. Some is like an isolation switch, which is in the middle of the batteries. So there was an 80s Alfa Romeo. They took the engine out, and the batteries were in where the engine would be. And in the middle of the batteries was a turn cord switch. That was their isolation. So I can imagine it's not going to be like your cut loops and your fuses, etc., etc. Okay. I'm just going to quickly show everyone the CRS, and then I will shut up. So who has crash data on their appliance? Most of us. Cool. The teams from the police, do you have this available? No.
We use Euro Rescue.
Euro Rescue. I don't work for Airbus, by the way. I'm just going to make that really clear. It's a really good tool. So CRS, this is the version we have or will have on all our appliances from April. Number plate recognition. So if we know the number plate, we can type the reg in, and straight away it's going to bring up that information for that vehicle. What I'm going to do, I'm just going to show you a couple of examples. We're going to look at a BMW i3. So we go into the BMW i3. Obviously, if we had the reg, we'd put that in. And straight away, it tells us we're dealing with an alternative fueled vehicle. And it says there, It's an EV or a plug-in hybrid. It's got a lithium and battery pack. Always assume the vehicle is powered if silent, as it's silent. Make sure the vehicle is immobilised and propulsion system deactivated. See deactivation. And then a reminder to our teams, never cut or touch any of the orange high voltage components. So if we click on this big deactivation button here, what this is going to do is this is going to go through step by step on how we need to deactivate that vehicle to make it safe for us to be able to conduct our extrication, etc. I'm going to go through it quite quickly, but it says there, block the wheels and set the parking brake. It then says, select the P position with the gear switch, see figure 1, and it gives us a pictorial of where that parking brake is on that vehicle. Okay. What we've then got, it says when the ready indicator in the instrument cluster is illuminated, press the start stop button once, see link 1. We run through this, and again, the pictures tell us where we're looking for that ready light or stop light to go out. And again, the start stop button that we're going to press to actually deactivate the vehicle. It then says use the service emergency disconnect switch, see link 2. So we click on link 2 and it says it's located in the engine compartment. How do we open the bonnet? Well, we've got a picture of the bonnet on the top left. So we can hit that, and that tells us the numerous ways on this vehicle on how we can open the bonnet. Okay, and in the driver's door, there's a little cord we can pull, and that will open it up for us. We then have obviously a traditional catch underneath the bonnet that we can utilise. So once we're in, we can then take this cover off and we can operate that fuse. And there's a pictorial on how to do that. Okay? So what happens then if you can't access any of that? The car's wrapped around a tree. How are we going to deactivate it? So what BMW have done for this particular model is they've been really kind to us. Is in the rear quarter, take that plastic cover off, and behind that cover is a cut loop. Okay? So it gives us a second way to be able to deactivate that vehicle if we can't get to the front end. We also, with the safety information, have access to how to deal with the vehicle if it's involved in fire, but also, more importantly, it tells us that hydrogen is produced if the vehicle is submerged. So submersion is a tactic. However, submerging the vehicles can, if the vehicle is damaged, generate hydrogen, which is then an additional hazard to us then resolving that incident. Okay. Unfortunately, there's no consistency. So if we now look at a Hyundai Ioniq, which we went to quite recently on the A34, again, we get told straight away that the electric vehicle is electric. However, this deactivation information is slightly different because it's a pull fuse in the front of the engine, or where the engine would be. Okay, so for us, this software forms part of our control measure at an EV or a hybrid related incident. Euro Rescue is very good, but it is not as detailed as this. The other good thing as well, guys and girls, is extrications are getting tougher. Seats are becoming electric. Door handles are becoming electric. If you look at the icons on the left, that's all information that can help us. So if I click on the picture of the seat, it gives me pictorials of how the electric seat works. What I'm aiming for, where I need to put my hands in that scenario where I might now be in BA and I quickly need to wind that seat down. Okay. Door handles. If we have disconnected the battery for whatever reason, if we can get hold of a key, there's an override that goes in the door handle that allows us to get in. We also, when we talk about keys, okay, it will tell us the preferred distance for that vehicle. As discussed earlier on though, they're all different, and we are looking at introducing Faraday pouches as a control measure for that smartphone, key, credit card, whatever it is that the occupier uses to get in that vehicle. It's not just cars. We also have a lot of electric motorbikes out there now, where again, we are provided with information of how to make that vehicle safe. Okay. And the last bit, I always show everyone this, is we spoke earlier on about electric buses and the batteries being in the roof. As a heavy rescue trainer, my lifting point is normally centre of gravity when I lift anything heavy. Where's now potentially my lifting point? or my turning point in the roof, innit? Could potentially be not, it won't be top heavy, but it's going to behave very differently to that of a normal bus. So actually when we are doing a tilt or we're lifting a bus over, we've now got all that added weight in the roof of that bus that we need to consider when we come to lift or move these electric vehicles. Guys, that's me. Any questions? Yeah, you got trucks. Trucks. Let's go for DAF. That's obviously not an electric one because this software does everything. But if it was, it would be in there.
You put a Scania up, yeah?
Scania, yeah. Yeah, what one? I'm guessing that
G-Series.
G-Series electric or hybrid?
Hybrid.
Whoa. Let's go 9.3, shall we? Truck or tractor? Boom, there it is.
So we go to the activation point.
On this one, it will be put it in neutral in park. Main switch. Under the main batteries at the back.
Yeah, cool.
Is that where it is?
Yeah.
Perfect. What's really good as well for those that are heavy rescue trainers or heavy rescue stations, can you see you've got the picture of the arrow at the bottom on the left there? So if we've got a running vehicle that we can't stall, we have CO2s on all our heavy rescue vehicles, we can chuck that CO2 into that air intake and that'll stall the engine. Okay, so again, this we're getting that information from our CRS. Cheers, John.
Thanks, mate. Excellent.
No worries.